information in case anybody has any questions or anything. At the end of the day, this is typical of our setup, okay? We will have Windows running in our environment. Inside of Windows, we will have our virtualization environment. For some of you, that's VMware. For most of us, that is VirtualBox, and that works. Inside of VirtualBox, we may have Debian, we may have Kali that we are using. For today's class, we are going to be using Kali, but in other scenarios, it might be Debian. And with Debian or Kali, we have two network adapters. One talking to NAT, giving us access to the internet, so we can download, grab stuff, what have you. The second adapter is talking on our host-only network, and it is on that host-only network that we have our target machine, in this case, Metasploitable. We have Metasploitable only talking on our host-only network, and we configure our VMs to not only allow our target machine, but we allow our machines to talk to Windows across that host-only network as well. Case in point. After I fired up, and I hope you've done this as well, after I fired up Metasploitable, I fired up Kali and I went to the IP address of Metasploitable, right here. For me, this didn't work, I didn't think it was going to work. For me, actually I'm going to save that right now. It's 192.168.56.197, but if you ever any doubt, of course, you do an Nmap scan. Now, with Metasploitable, we can log in and check the IP address, but that's not how we do pen tests. We run an Nmap scan on our network, and we try and discover the IP address. Like that, okay? And then it will give us the IP address we want to target. Perfect, straightforward. But that IP address can also be used in our host environment. This is my Windows, and you can tell by the green background that I set up for Firefox. It's a fly fishing themed browser template, whatever you want to call it. If I go to that IP address, I can also talk to it from Windows down, and that's not a bad idea when you're doing pen testing. It's not always the best idea when you're doing malware analysis, but when you're doing pen testing, be able to go from the host environment down to the virtual machine is never really a bad idea. Keeping in mind that when we're talking these terms here. You've got your laptops running Windows. In our case, most of us are using VirtualBox for our VM software, and then we'll have one or more guest OSs that we can talk to. When set up properly, we can have Windows talking to our guest environments over the host-only network, and that's going to be kind of our goal. Oh, yeah, don't worry about that. If you need to, you can set up the network settings here. We've talked about that. We've also talked about the network scan. Now, this is more along the lines of what I was expecting when we did our scan last time together, that we would see the gateway and the DHCP server address. We don't see those, but then we can do a detailed scan, and we've already done this, and it'll give us a list of services. And with those services, you can do specific attacks like the Unreal or the VSFTP. So let's do the VSFTP attack again and see what we get, okay? And I'd like you to follow along at this point, keeping in mind that I am recording. If you do get behind, let me know, but it shouldn't really be that big of a deal, okay? Now, I have a machine here. It's called Metasploitable. I am going to make a directory called Metasploitable. Change into that directory, and this is where I'm going to put my artifacts from my scan. It's a really good idea from a workflow point of view to have a directory structure in place. Now, keeping in mind the last time we talked, I told you, not last time, but when we were talking reporting, I mentioned that each time you do a new attack, you should do a new instance of Kali. But we're not doing that. We're using the same instance of Kali for the entire semester. So for our workflow, it makes sense to have separate directories for separate attacks. Okay? First thing I want to do is I want to try and attack the VSFTP. So, as before, we're going to do MSF console. It will start up the MSF console for us, and then right away we will try our attack, specifically our VSFTP daemon attack. And it was use. Let me check my notes so I don't mislead you guys. Use exploit tab, ex tab, un tab, ftp tab, vs tab. By using the tab character, it will autocomplete what you want to type in, and you are less likely to have problems. As always, show options. The port should be okay. We need to set the rhost. Our hosts. And again, for me, it's 192.168.56.197. You must enter your IP address. You must understand your environment. All right, and let's try an exploit. Let's see. It looks like it started a shell. It shows that I am logged in as root. Awesome. One of the first things you want to do is steal credentials so you can log in as a regular person, so you can log in without having to use this exploit. The way that we do that is the following: cat etc password. If there are no problems with the terminal you have running here, it should dump out the contents of the password file. Perfect. It starts with root and it just goes down from there. Once you have that highlighted, you can copy it, and then you can launch a text editor and paste it, and boom, you've captured the password file. All right, I'm going to save this file. I'm going to save this file again in my Metasploitable directory, and I'm going to call it metausers.txt. Perfect. Now, if I'm logged in as root, I should be able to take a look at the shadow file. Cat etc shadow. And it gives me the contents of the shadow file, including all of the password hashes. So double click and just move your mouse down so you highlight everything from root down to Stan. Right click, copy, go back into your notepad, your text editor, Control N for a new one, and paste. And we want to save this one again in Metasploitable, and we're going to call it meta_pass.txt. Okay, so I have my session running here. I have my remote session running here. I'm stealing credentials. Let's see what I can do with it now. At this point, what I normally do is I open up a new tab and start working from a new tab yet again. Okay, I'm not in the right directory, so let's go into the Metasploitable, and there are my two files. As we did with John the Ripper before, we want to unshadow meta pass, meta users, and redirect the results to meta usepass.txt. Doesn't matter what you call the files. right? Okay. So you need to, of course, use the sudo command. I'm not used to doing this as a regular user. This is something that's bothering me about Kali, and you guys get to hear me complain about it. Historically, we did everything as root. For whatever reason, and I'm not really sure what it is, now when you set up Kali, you do it as a regular user. It's almost like they're trying to make people use Kali as their daily driver in Linux, and I don't think that's a good idea. I don't like this thing, and I might just force a workaround in a future class, because my default is to do everything as root, not as a user with the sudo command. Again, Kiki, thanks for that sudo bang bang. That was really handy. Okay, so now when I do an ls, I have my meta user pass text file. If I take a look at it, it doesn't look right at all. Because I did it backwards. You actually have to do this in the right order. If you don't do it in the right order, it doesn't create the right file. And I did it in the wrong order, and that's what we're seeing here now. There. Now it looks like a proper file. And right there, you just saw the benefit of somebody verifying their work before moving forward. Okay? Again, what did I do? Just to remove any of the confusion that I did. In my first tab that has the shell, I grabbed the username and password file information from the etc password and the etc shadow files. I saved them locally and I merged them into a single file that we can then run John the Ripper against. And we're going to do that now. Sudo bang bang. Okay? And then very quickly it finds the passwords. Not only for the ones that we were looking at, but specifically extra ones as well. It found the password for the sys user, found the password for the klog user, which is really interesting. Okay? So we've been able to grab some username passwords in this environment. Are there any questions? Did that make sense? Okay. The command is right here. Which one? The last one? The last one is the John command. And the John command is this one here. Sudo John to crack whatever you called the merged file. For me, it was meta-use-pass, but whatever you called the file that you generated when you did the unshadow command, that's the file you run John against. But apparently we have to do it with the sudo command first, which, is not my fave. Okay? Any other questions? Okay. Let's say you don't have something like this. I'm going to reference that document. I'm not going to follow it in great detail, but let's say for argument's sake that you don't have the ability to do this root remote session because of a vulnerability in either the IRC daemon or the VSFTP daemon running badly. Let's say all you've got is an SSH session and a website, for example, DVWA. As always, the username for, let me start from the beginning. What I'm going to do now is I'm going to launch my browser. In Kali, there's 14 different categories of different types of applications. We were talking about report writing, and I said there were a couple of tools. Here's Daedalus and Faraday. They come canned, built into Kali Linux for you to use. We don't really care about that. What we care about is launching our browser, our web browser, which should be Firefox. Okay? Once we have Firefox up, we want to navigate to the IP address of our target machine. For me, again, it's 197. And when we do that, we see all of these websites that we can attack. Let's take a look at DVWA. If you recall, the username is admin and the password is password. Once you're logged in, verify the security level. Security level is high. That doesn't really work for me, okay? So I want to go in to DVWA security and set the security level to low and submit. So now it says low here, and when we look at it in the security part, it says low as well. Please note that this version of DVWA is a little different than the one I had you set up in Debian. This one doesn't have impossible as the fourth level of security. There are 4 levels in DVWA. This one only has 3 because they didn't want to keep it unhackable, I guess. I'm not really sure why, but they took out that 4th option as a way of trying to attack this site. So just because we see 3 here, don't assume that that's always just 3 for DVWA. There is a 4th level. Okay? Now that we set our security level to low, let's take a look at command execution. We've seen the ping before. If we want to ping a server, we can ping 192.168.56. Let's try pinging our gateway address and see if it'll give us anything. Well, it didn't like that. It didn't get any packets of data. Obviously, our gateway isn't responding. But that's okay. That's not what we care about. We can end the ping command, and using command chaining and command injection, we can try something else, like the ls-al command. And when we do that, right away, the ping command ends, and the ls command works right away. Perfect. Perfect, perfect, perfect. That means we can do command chaining. Let's take advantage of that. Let's end our ping command and start a new command called cat. And what we want to look at is the password file. And it gives us our password file. Awesome. Are we lucky enough to get the shadow file? Of course not. Why? Well, let's find out. When I run the whoami command, it shows me who the process ID, the process ID's user ID, or the process's user ID. That's what I was trying to say. The process's user ID is identified with the whoami command in this scenario. And it's telling me that when I'm running these web things, I'm running as www.data. I'm not running as root, which is why you never want to run any of your server processes as root. If somebody is able to shell out using that, they run as root. And a lot of the attacks we are going to do going forward exploit that, that very real world problem. Okay, so let's go back and take a look at the password file again. We can't get the passwords, but we can get the users. Now we're not going to go through all of them. We're just going to focus on these 4 users here. So again, I'm going to fire up a text editor. Question? Did anybody have a question? Okay. I'm going to fire up a text editor, and I am going to copy those 3 users. Cartman, Kenny, my headset's dying, so my voice is going to change. I apologize, but my voice is going to change because my Bluetooth headset just died, the battery. Kyle and Stan. So we're going to use these 4 users to try and attack this system. Again, we file, save as, and again, in Metasploitable, we are going to call this DVWA users.txt. Yeah.
I don't see those 4 users at the end of my
You don't?
No.
Does anybody else not see those?
I don't see them either.
Okay, so you have the wrong one. I'll put the right one up. I thought I had this sorted. I apologize. You can also do SNMT, SNMP, and what was the other one? It wasn't stat. It was Klog. So rather than saying Cartman, Kenny, Kyle, and Stan, because it's not going to work, then what I want you to do is we're going to use, you know what, I'm not going to trust my memory on this one. So we saw Klog and sys were able to give us passwords pretty easily, so that's what we're going to use. Once I get you the right so in our list of users, we could try all of these, but we're going to focus on Klog and sys. Was it sys? I think it was sys, wasn't it? I'm just going to make sure because I don't want to waste our time. Yeah, Klog and sys were crackable. Perfect. Let's do that. Bam. I just shut down the wrong one. Okay, so I'm going to... That's okay. That's okay. So now I'm going to save this as dvwa users.txt. And I'm going to save those in my Metasploitable directory. Okay? Thank you for whoever told me that. I appreciate it. Obviously, I uploaded the wrong OVA file. The OVA file I should have given you should have had the 4 main characters from South Park. And that's on me. That's totally on me, but that's okay. I can now take this information and work with it. In our initial scan, I'm going to minimize this text editor, and I'm going to go back to page 1 of my scan. In my initial scan, which I have since closed for whatever reason. All right. Doesn't really matter. In our list of services, we're going to do it again just so that I'm not playing smoke and mirrors. I dislike doing these things without being completely wide open and honest with you. One of the services that was returned was SSH. Now, if SSH is not configured properly, now that we have a couple of usernames, Klog and sys, knowing that SSH is running, we might be able to use this and try and figure out the passwords. So let's try this. It works a lot better with Cartman, Kyle, Kenny, and Stan, but we're going to try it anyway. Okay, so I've got my services here. I'm going to open up another tab yet again, only because I like having separate tabs so I can jump back and forth and find the important things. One of the tools that comes standard, perfect, with Kali is a network password cracking utility called Medusa. There are 3 main network passing utilities, network password cracking utilities that we have available to us. The 2 that we talk about in this class are Medusa and Hydra. There is also Hashcat that can be used for network hacks, and I think you can also use John the Ripper for some network hacks as well, but that's well out of scope of this class. We're going to focus on Medusa, and we're going to focus in a future class on using Hydra, because Hydra is actually better for website password cracking than Medusa is. With Medusa, you have to specify a password file. And we have a password file. If you type in ls-al usr share and then word lists, tab is your friend, you will see that there is this large compressed file called rocku rockyou.text.gz. Many years ago, there was a website called RockYou that was used for photo sharing and stuff like that. It's still around. It does some Facebook, really dubious Facebook stuff these days, but it doesn't matter. Back in the day, they had usernames and passwords, and they stored their passwords in plain text. Of course, they were compromised, and of course, everybody was able to dump out the passwords. And there's something like 16 million passwords in this file, unique passwords sorted by popularity in this file called rockyou.txt. It is so big that they have compressed it. And what we want to do is we want to uncompress this file. If you have a gzip file, the easiest way to try and uncompress it is gunzip or gunzip, and then usr share word lists, and then rock tab is your friend, so that you end up typing in gunzip and then the full path starting with a /. Basically, you want to unzip rockyou.text.gzip. And of course, sudo bang bang. Wants my password. I really don't like doing that, but that's okay. Thanks, Kiki. I don't know if Kiki's on, but thanks, Kiki. That sudo bang bang is quite appreciated. So now, when I do my ls again, double click, highlight, and middle button, it'll paste including the carriage return. Now we see we have the RockYou file, which is 139 megabytes in size. WC-L will tell us how many individual lines are in that file. In the USR share words lists rockyou.txt file. And it is 14 million unique passwords taken from a real site. This is a great dictionary. Recall I was talking about dictionaries when we were talking about passwords and doing password audits. This is a great dictionary to use for password audits. It's 14.5 million real-world passwords. Okay? And by the way, all of this is inside this Word document here. Where we are now, we've set our security level to low. We've done some initial checks. We've grabbed the passwords. We're not using these 4. We're using the other 2. And we're unzipping our password file. If Medusa isn't installed, sometimes it's not installed. That's why I did a test fire, but it is installed, so we're okay. Next thing we want to do is try this. And here's the syntax for the command right here. You use the Medusa command. You specify uppercase U for users. If it's an uppercase, it's a file. If it's a lowercase, it's an individual instance. Same with the password. If you're going to use a password list, it's uppercase P. If it's a lowercase p, then it's an individual password. And you may say, well, who would do that? And I'm going to explain that in a minute. Uppercase M is for the service, and we're going to attack SSH. We know it's running. The host is the IP address of the machine you need to attack. And the -uppercase O is success out. So we're going to write out to a success.txt file. So we're going to type that command in. And it is Medusa. Okay, so maybe it's going to let me run without being root. Medusa dash. I need to be in my Metasploitable directory. There is my dvwa users.txt. Perfect. So Medusa dash uppercase U dv tab. Perfect. Dash uppercase P for the passwords. / usr share tab word share ro tab rockyou.txt. Perfect. Dash uppercase M for the service SSH. Dash lowercase h for the host that we are going to target, and it is 192.168, and for me, .56.197. You must know your environment. And then we're going to output to success.txt. Providing I don't have any typos, this should go through and try and crack my passwords. That was frighteningly quick. Awesome. Okay. Right away, I'll try and highlight it so you can see it. Right away, it finds a password. And the Kyle ones were a little bit better than this one, but that's okay. What's going on here is that now it's iterating through the dictionary again. And this is where you can run into trouble. The first one it found very quickly, but let's say that the first word in my file, like I have klog and sys. Now it's trying to figure out the password for sys, and it'll eventually get there. But what if the password for sys isn't in the RockU file? It's going to iterate through all 14.5 million records before it moves on to the next entry in the text file, which can be problematic. So what do you do about that? Let's take a look. Rather than use a text file, it's going to complain, but that's okay. Rather than using a text file with usernames, why don't I just have two separate sessions running? Instead of, and here's my command that I typed in last time. Rather than doing uppercase U and specifying a list, as I said, you can do a lowercase u and specify a username. And then you can just let that run. Okay? Highlight that text and just let that command run. Open up a new tab. And rather than doing klog, we're going to do our other name, which is sys. Okay, so I can have two separate sessions running concurrently. And then if one of them doesn't exist in that password list, I am not sabotaging myself. Any questions on that? Okay, long story short, I should have let that run. I shouldn't have hit Control C. Oh, I didn't. Good. Long story short, normally we put our usernames in a text file and then we just let the password hack run and run and run. As you can see, there is great benefit in limiting the number of connections you allow remotely for an individual user. If that is the security measure that is in place, then you get a list of users and you iterate through a password file. So you, instead of going through for each user, try all the passwords, you go through a dictionary of passwords, and for each password, you try each user. All right. Tools like Medusa and Hydra will let you iterate through the passwords first and then the usernames. For each password, try each username. So there are different ways of running these. Very quickly, you will figure out which is the better one, which is the worst. And by the way, I don't sanitize these files. I should have mentioned it before. As you can see, password 39 in this dictionary is an F-bomb. I do not clean these things up. These are, and you downloaded and ran your own, which is fine. These things are real world. These are the real world passwords that we see. I apologize. That's what we get. That's what we're stuck with. Okay? That's not the worst thing in this dictionary file. So don't look too closely as things scroll by because it gets pretty crude. Any questions? Does that make sense? We can also do SQL injections. Let's take a look at some SQL injections right here. It wants a user ID. So if we recall correctly, we can do what we did before. We took a look at the source code. View page source control U doesn't work for whatever reason. And when I take a look, there really isn't much here that I can use. Okay. Basically, that's it there. There's nothing available. So let's try an empty thing. Doesn't look like it works. Let's try A. That doesn't work. Let's try 1. Oh, we get something. 2. Perfect. 3. Looks like there's a bunch of users in this system. Oh, it looks like there's 5 users in this system. Okay. So the first thing we want to try is seeing if we can do some kind of an SQL injection. In today's handout, we are bottom of page 14, moving on to page 15. Okay. I am going to breeze through this, but it basically works like this. Tick or 1 is equal to 1, and we either try double dash or the hash. If we go back and check the services that we had, we have MySQL. Perfect. Oh, we also have Postgres. It could be either one of these databases driving that website. So we don't know if it's a hash or if it's a double dash. Let's use the SQL standard. It doesn't like that. And it says your MySQL server version. Right away, this is why we don't return error messages. Right away. Oh, crap, I just closed mine down. I'm sorry. Let me get that back up here. Right away, we have an error message. Perfect. Right away, we have an error message that shows information about the database, and there's an extra tick that it didn't like. Perfect. So let's try that again. Tick or 1 is equal to 1. And let's try the hash, and it returns all 5. If you want to try the wildcard, that should work as well. Okay? Notice that it returns the ID is the injection. All right? It's not pulling the ID from the database. The ID is actually my SQL injection. That is a clue. It then grabs what looks like a first name and a last name. All right? So we can start using this and try to figure out our environment. If we're going to do this, we are going to want to try and do what's called a union. What a union does is it allows us to add one SQL statement to another SQL statement and try and retrieve information. Okay? And that's what we're going to try and do here. It's a really blind way, it's not blind SQL injections, but it's a really good way of trying to discover what's going on. Okay? So we can do tick or 1 is equal to 1, and then order by 3, or 2, or 4, or 5. We think we have 3 columns here. Doesn't really look like it, but I'm going to try and sort it by the 3rd column. If you recall SQL1, there's different ways of sorting the results. You can sort it by the column name, you can sort it by the formula used for a calculated column, or you can sort it by the order that the column was requested. In this case, I'm doing the last option, where I say order it by the 3rd column in the SQL statement. And it doesn't like that. So right away, I don't have 3 columns. I must have 2 columns, right? Oh, what's wrong? I forgot my hash. So let's try 3 and then try the hash again. You really need that hash. That's a better error. Unknown column 3. So there is no column 3. Let's try column 2. So now we know that this query is probably select first name, last name from some table, and we know that's it. So if we're going to do a union injection, we must include 2 columns in that union statement. Okay? And at this point, it gets a little big and unwieldy to type in. So again, what we do is we use a text editor so that we can more easily type these things in and not have to worry about getting it right in that small little area here. All right? So we know that works. We know this works. So let's try building our query around that. We know that this query works, and we want a union select null, comma, and let's say version. Like that. Hopefully MySQL will let me try that. Let's see if you can make sure that you can see that. There we go. That easier to see? I like that.
Yep.
Yep, good. So now it's doing a union. It's returning all the results from the first part of the query and all of the results from the second part of the query, which was the version statement. Okay? And again, we are on page 16 of that handout. Do you guys have anything after this class?
I don't.
Is it okay if I bleed over a little bit into the 6 o'clock hour?
For me, yeah.
Yeah? If you have to leave, that's fine. I won't hold it against you. If you need to leave, if you need to bail, totally fine. If you got to go get to jobs or families or whatever, I totally get it. I'm going to bleed over a little bit. All of the information is in this Word document here. No, that's not it. Is in this Word doc. That's not it. There we go. Is in this Word document here. So we're going to take a look at the different steps, starting on the bottom of 16 and moving on to 19. Okay? So we've got the version. Let's see the username. And that's why we use the text editor. Oh, it's running as root. Well, this is insane. They're running this database as root. That's insane. But that's a possibility. If you were to do the exact same thing that you did on your setup, you would see the username that you used, that you configured in your settings file. Okay? Also, this is getting tedious. Our query always uses or 1 is equal to 1. That's always going to test true. It's always going to return these 5 records. What I like to do after a while is change the or 1 equals to 1 to and 1 is equal to 0. And then union that with the second thing that I want, which is in this case the username. And when you run that, this never tests. 1 never equals 0, so this first query will never test true. It doesn't matter that it tests false. It's the beginning of a result set that I can union and append what I'm looking for to the end of it. Okay? So, just like I stopped using real IP addresses in my ping command, I just did the semicolon and did my command injection. I also like to do and 1 is equal to 0 in my SQL injection, so I don't get the same results, useless results over and over again. In this case, it was 5 records. Imagine if it was a database with 14.5 million records in it, and those were unique passwords. There are far more users than the 14.5 unique records would have reflected. Okay? So we're going to change it from or was 1 is equal to 1 to an and 1 is equal to 0. And that works really well when you're unioning that with a second result set. And that result set, the number of columns must match the original result set column count, which is why we did the order by. Okay? Next thing we want to try and figure out is the database. Change data user to database and see what the database is called. Database is called DVWA. I should really be keeping track of this. User, root, database, DVWA. I really should start keeping track of this information. Okay, what do I want to look at next? Let's grab the table names and see what that gives us. Select null comma, and I am on bottom of page 16 at this point. Table underscore name from information dot schema, information underscore schema dot tables. Okay? No semicolon. You don't need a semicolon. Okay, obviously you're not going to put a carriage return, but I did a line wrap so that we can see what I'm typing in, so you can see what I'm typing in. And when I submit that, we get a lot of table names, a lot of uppercase table names that are probably system tables. And then we get a couple with lower column names. A lot of them still look like system tables. Accounts might be interesting. Blogs table, that might be interesting. There's a lot of stuff here, but we're looking for the obvious ones. And we have a couple of real obvious ones right here. Users and guest book. Okay? Before we can just dump everything from users, we have to make sure we have the right number of columns. Okay? Got that. If we want to see what the columns are called, we need to modify this query a little bit. We took table name from information schema.tables. Let's take column name. And again, it's from information schema.columns. But this time we want to limit it where the table name is equal to users. Okay? So now we're trying to get all the columns for the table users. This again should look very familiar to the system catalog work you did in semester 1 or semester 2 and 3 with DBMS 1 and 2. It is all and always related. Highlight that, paste it as my injection, and you can see right away you have user ID, first name, last name, user, which is probably a username, a password, and some kind of an avatar field. The last login and failed login seem not to be in this table, but that's okay. We don't need those. But right away, this is why we just can't say union select star from users, because this table has 6 columns. The other query that we are unioning only has 2 columns, so they are incompatible. So we can only pull 2 things from this table. Let's pull the username and the password and see what we get. And I'm going to keep that there because that gave us a lot of really good information. I'm going to do it again. Union select user, comma, password from users. I think that'll work. Let's try that and see what we get. If it doesn't work, we just keep tweaking until it works. Look at that, it worked. So I've got admin, And does that look like a plain text password? That doesn't look like a plain text password to me. But back here, table was users, columns, user, and password. Should be keeping notes of these things. Now, I've got that. I'm going to start stealing this information. Admin and that password. Gordon B. password. And I can do this. I'm going to take an extra minute here. I can do this. Copy, paste, colon, double click, copy, paste, and enter. And then wash, rinse, repeat. But that is long and tedious. There are string concatenation tricks that you can use. And I'm at the top of page 18 of the handout, where rather than simply selecting username and password, what you can do is you can select a string concatenation. So I'm going to select null, and I'm going to concatenate user and password with a colon. It is the concat function, and I don't want first name and last name and username and password. I want user, comma, let's see if that works, comma, password. I don't know if that's going to work, but let's try it. From users, let's see if that gives me what I'm looking for. Look at that. And now I've got a username password that I can just copy and paste. Copy and paste. And you can take it even further. You can have this all go to a text file and then run some data sanitizing and some standard data migration tricks will give you the same kind of information with even less extra characters output. You can just get rid of all of the extra irrelevant information, and you can quickly come up with a username password combination. Okay? Now, those do not look like SHA 256 or 512 passwords. All right? They actually kind of look like crappy old raw MD5 passwords. Okay? So if you take a look at the halfway down point or close to the bottom point of page 18 of the handout, we need to save our work. Again, we're in Metasploitable. We're going to call this one dvwa underscore app users.txt. So now we've got this file created. We can go and you know what? Oh, it found the password. The password for sys was Batman, but we knew that. New tab. I'm going to zoom in so you can see what I'm doing. I'm going to change directory into Metasploitable, and there's my DVWA app users. And now I can do again, John dash format is equal to raw dash MD5. Those look like old MD5 passwords, and they're not going to have the salt somewhere that I can easily find them. So I'm just going to try this format, raw MD5, and it's dvwa underscore app users dot text. Just like that. Damn it. Thank you, Kiki. And my password is password, and right away we crack the passwords. All right? Any questions? Okay. I know I went fast and furious. I'm going to stop recording